Ever wondered how your muscles actually work? Muscles are fascinating engines of the human body, responsible for every movement you make, from the blink of an eye to running a marathon. But what's the science behind muscle contractions, growth, and adaptation to physical activity? Let's dive deep into the intricate mechanisms that make movement possible. The human body has over 600 muscles, categorized into 3 types. First, skeletal muscles or voluntary muscles. These are the muscles you can control, like when you lift weights, type on a keyboard, or even smile. Skeletal muscles help you move by pulling on bones, and they're connected to those bones by tendons. These muscles are the ones you work on when you hit the gym. They're responsible for strength, flexibility, and movement. Second, smooth muscles or involuntary muscles. You don't think about these muscles, but they're working 24/7 behind the scenes. They're found in your stomach, intestines, blood vessels, and even your bladder. Smooth muscles handle all the essential jobs you don't have to think about, like digesting food, regulating blood flow, and controlling your breathing rate. They're involuntary, meaning you can't consciously control them. You can't tell your stomach to stop digesting, right? Third, cardiac muscle, the heart's powerhouse. Now this one's special. It's found only in your heart. The cardiac muscle pumps blood throughout your body, keeping you alive. Like smooth muscles, it's involuntary, so it keeps beating without you having to think about it. Cardiac muscle is super strong and never gets tired. Your heart beats roughly 100,000 times a day. In common terms, think of your muscles as a team with different jobs. Skeletal muscles are the workers you can command, like lifting, walking, running. Smooth muscles are the behind-the-scenes crew running the vital systems like digestion, blood flow. Cardiac muscle is the MVP, working round the clock to keep you alive. Every type of muscle is designed for a specific purpose, and together they keep your body moving, functioning, and thriving. Cool, right? But how do they actually work? Let's break it down with the sliding filament theory. First up, your muscles are made of long, cylindrical cells called muscle fibers. Inside these fibers, you've got tiny structures called myofibrils. These myofibrils are packed with contractile proteins and are divided into functional units called sarcomeres. Now, sarcomeres are where the magic happens. They contain 2 main types of filaments: thin ones called actin and thick ones called myosin. Picture myosin as having little heads that grab onto the actin during contraction. So, how does muscle contraction actually work? It all starts with a signal from your brain. This electrical signal, or action potential, travels through motor neurons to your muscle. When it reaches the neuromuscular junction, it releases a chemical called acetylcholine, which kickstarts muscle activation. Next, the signal triggers the sarcoplasmic reticulum to release calcium ions into the muscle fibers. Calcium binds to a protein called troponin, which moves another protein, tropomyosin, out of the way, exposing binding sites on the actin. Now, myosin heads can attach to these binding sites, forming what's called a cross bridge. Using energy from ATP, the myosin heads pull the actin filaments toward the center of the sarcomere. This action shortens the muscle, causing it to contract. Finally, when the signal stops, calcium returns to storage, tropomyosin blocks the binding sites again, and the muscle relaxes. And that's how your muscles work, folks. Now let's talk about how muscles grow. The concept of hypertrophy and adaptation. Muscle growth, or hypertrophy, occurs when the muscles adapt to stress from exercise. Here's how. When you lift weights or do intense physical activities, you're causing tiny tears in your muscle fibers. Don't worry. This is totally normal and actually necessary for growth. Once the workout is over, your body jumps into repair mode. It fuses muscle cells together to patch up those tears. But here's the cool part. It doesn't just fix them. It makes the muscles thicker and stronger than before. After your workout, your body cranks up muscle protein synthesis, basically the process where it builds new proteins to repair and strengthen your muscles. To help this process, you need to feed your body with high-quality protein, like chicken, eggs, fish, or whey. Think of protein as the raw material your body uses to patch up and grow your muscles. Hormones like testosterone, insulin, growth hormone, and insulin-like growth factor 1, or IGF-1, play key roles in muscle growth and repair. Your body is smart. It adapts to the stress you put on it. When you keep challenging your muscles by lifting heavier weights or doing harder exercises means progressive overload, your muscles respond by growing in size and strength. Without progressively increasing the resistance, your muscles won't have a reason to grow. This is why progressive overload, or gradually increasing resistance, is essential for continuous growth. In simple terms, muscle growth is like fixing and upgrading a house. Workouts cause damage or micro tears. Think of it like knocking down walls. Protein is the building material your body uses to repair and improve those walls. Hormones are the construction crew directing the repair process. Over time, your body renovates the house to handle bigger and better challenges. Your muscles get stronger and bigger. So, if you want to keep growing, you have to keep challenging your muscles and giving them the right tools. That's how you build strength and size. How do muscles adapt to exercise? When you work out, your muscles actually adapt to the type of exercise you're doing. Here's how it works. First, endurance training like running or cycling. When you do a lot of endurance activities, your muscles get better at using oxygen to produce energy. Why? Because your body starts making more mitochondria, the little energy factories inside your cells. Plus, your muscles grow more capillaries, which are tiny blood vessels that help deliver oxygen and nutrients to the muscle. This makes your muscles more efficient at lasting longer without getting tired. Second, strength training like lifting weights. Now, when you lift weights, your muscles respond differently. They get bigger and stronger because the individual muscle fibers grow. This is called hypertrophy. But it's not just about size. Your brain and nervous system also get better at coordinating your muscles. So, you can recruit more muscle fibers and use them more effectively. This type of training also targets the fast twitch fibers, which are great for explosive movements like jumping or sprinting. Third, flexibility training like yoga or stretching. When you focus on flexibility, you're basically teaching your muscles and connective tissues, like tendons, to stretch further. Over time, this increases your range of motion. Your body also learns to relax muscles better during a stretch by dialing down the reflex that normally tries to stop you from overstretching. That's why consistent stretching makes you feel less stiff and more mobile. Now let us discuss how muscles use energy. When your muscles work, they need energy to contract, and that energy comes from breaking down food. Your body has some clever systems to turn that food into fuel for different types of activity. Think of ATP or adenosine triphosphate as the ultimate quick cash for your muscles. It's the form of energy your muscles use to contract. But here's the problem. Your muscles only store a tiny bit of ATP, enough for a few seconds of effort. So once that runs out, your body has to refill the ATP supply using different systems, depending on how hard and how long you're working out. Your muscles have three main energy systems they rely on, like backup plans for different situations. First, phosphagen system for quick explosions. This is your instant energy system. Imagine you're doing a heavy deadlift or sprinting for 10 seconds. This system kicks in to keep you going. It uses something called creatine phosphate to recharge ATP super fast. The catch? It runs out just as quickly as it kicks in, so it's only good for short bursts. Second, glycolysis for shorter, intense efforts. Now, let's say you're doing a high-intensity workout or running a 400-meter dash. Your body turns to glycolysis, where it breaks down glucose, sugar, from carbs to make ATP. Here's the twist. It doesn't need oxygen, so it works fast, but it's not perfect. It creates lactic acid as a byproduct, which is why your legs might burn when you're pushing hard. This system lasts about 1 to 2 minutes. Lastly, aerobic system for the long haul. For longer, steady activities like jogging or walking, your body uses the aerobic system. This system is like a slow but efficient engine that burns carbs and fats with the help of oxygen to keep your muscles fueled for hours. It's not great for quick bursts, but it's your best friend for endurance activities. No matter what you're doing, sprinting, lifting, or jogging, your body smartly switches between these systems to make sure you don't run out of energy. Cool, right? Now let's discuss the importance of recovery in muscle health. Muscles grow when you rest, not when you work out. You know that burn you feel during a workout? That's your muscles getting tiny tears from the stress. But here's the thing, they don't get stronger while you're exercising. The real magic happens when you rest. That's when your body repairs those tears, making your muscles stronger and more resilient. Skipping recovery is like pushing a car without refueling. It just won't go far. So then what are the key recovery strategies? 1. Sleep, the foundation of recovery. Think of sleep as the ultimate repair time for your body. During deep sleep, your body releases growth hormones, which are key for rebuilding muscle tissue. Without enough sleep, or 7 to 9 hours of sleep a night, your muscles can't recover properly, and your performance suffers. 2. Nutrition. Your muscles need protein to repair and grow. A good target is roughly 1 to 2 grams per kilogram of your body weight. For example, if you weigh 70 kilo, that's about 100 to 150 grams of protein daily. After a workout, your muscles' glycogen stores or the energy reserves get depleted. Eating carbs helps refill them, so you're ready for the next session. A balanced diet is non-negotiable if you want your muscles to thrive. 3. Hydration. Don't forget water. Even mild dehydration can mess with muscle function and slow down recovery. Drinking enough water, especially after a sweat-filled workout, keeps your muscles working optimally and flushes out toxins. Lastly, stretching and massage. Ever feel stiff or sore the day after a workout? Gentle stretching and techniques like foam rolling or massage can help. They improve blood flow, reduce soreness, and keep your muscles flexible, which lowers your risk of injury. In everyday terms, recovery is like recharging your phone. Your muscles need downtime to recharge and come back stronger. So, don't just focus on the workout. Give equal attention to rest, good food, hydration, and flexibility work. If you skip recovery, you're basically leaving gains on the table. Now, the interesting part. What is muscle memory? Muscle memory is a fascinating concept. It's the ability of your muscles to remember certain movements and actions, even after a period of inactivity. It's like your body getting so familiar with a specific motion that it becomes second nature, even if you take a break from it. For example, think about riding a bike or playing a musical instrument. Even if you haven't done either in years, your body remembers the movements, and you can quickly get back into it. That's muscle memory in action. How does it work? While it may sound like something stored in your muscles, it's actually a process that involves both your nervous system and muscle fibers. Muscle memory starts with the nervous system, especially the brain and spinal cord. When you perform a repetitive action, your brain creates neuromuscular pathways. These are like highways that connect your brain to your muscles, making the movement smoother and more efficient over time. Think of it like learning to drive a car. At first, you're consciously focusing on every step, like steering, braking, shifting gears. But over time, it becomes automatic because your brain has built those pathways. On a physical level, muscle memory also involves changes to the muscle fibers. When you regularly train a muscle, it adapts by growing and becoming more efficient at contracting. After a period of rest or inactivity, those muscle fibers can bounce back quicker than when you first started training, because they've already undergone the adaptation process. When you stop exercising, your muscles don't lose all the gains you made. Thanks to muscle memory, the muscle fibers don't return to their original state. They just shrink a little. This means that when you resume training, your muscles remember their previous state and can regain strength and size much faster than when you first started. So, whether you're trying to get back into the gym after a long break or pick up an old hobby, muscle memory makes sure you don't have to start from zero. Your body has already stored the blueprint for those movements, making it easier to get back to where you were. Cool, right? Finally, some interesting muscle facts. The tongue is the most versatile muscle, essential for speech and eating. The gluteus maximus is the largest muscle in the body. The stapedius, located in the ear, is the smallest muscle, controlling vibrations in the eardrum. Muscles make up about 40% of your body weight. Muscle memory allows you to quickly regain strength and size after a period of inactivity. In essence, your muscles are incredible biological machines, turning food into energy, enabling movement, and adapting to challenges. Whether you're lifting weights, running, or even typing, your muscles work tirelessly to power your life. By understanding how muscles contract, grow, and adapt, you can train smarter, recover better, and unlock your full potential for strength and performance. Remember, your muscles are your body's engine. Fuel them well and challenge them often to stay strong and resilient. See you in the next video. Until then, stay healthy.